Alright, let's look at the homework 9.3, problem number 7. Alright, let's find orthogonal trajectories. Alright, so we have a bunch of ellipses given, and we want to find orthogonal trajectories. Alright, so first thing is I'm going to just go ahead and find the derivative. So take the derivative with respect to x. So we get 2x plus 2 times 2 is 4y, and then we have a dy over dx is equal to, k is a constant, so the right hand side is going to be 0. Alright, so let's find the dy over dx. I'm going to first subtract the 2x. So we have 4y times dy over dx is equal to negative 2x. Then we're going to just divide through by 4y. So we have a dy over dx is equal to negative 2x over 4y. Alright, then we can cancel 2 and 4, so there's going to be 2 left over. So we have negative x over 2y. Alright, and then we can think of this as m1. So think of this as a slope number 1. So I'm going to call it m1. Alright, then m2 would be a negative reciprocal of this guy. So the m2, so I'm going to go here. So m2 is going to be the derivative of the orthogonal trajectories. So I'm going to have dy over dx. But this, we want it to be negative reciprocal of m1. So we take the negative reciprocal. So negative, negative, so it's going to be positive reciprocal. So put it upside down. So you have a 2y over x. Alright, then we're going to solve this differential equation. Since this is a separable equation, I'm going to first divide through by y. So we get the 1 over y dy over dx is equal to 2 over x. Then we can integrate with respect to x. So we integrate with respect to x, right? Then we can cancel, dx on top and dx on the bottom. Right? So this is going to be, right? Antiderivative of 1 over y is natural log of absolute value of y, which is equal to, right, 2 times natural log of absolute value of x. Then you would have plus some constant. I'm going to probably call it c1. Alright, then we want to get rid of natural log. So I'm going to raise e to both sides. So you have e to the natural log of absolute value of y is equal to e to the, right, before we do that, actually, I'm going to move 2 up here. Right, so we're going to have natural log of x squared. We don't really need the absolute value because of the square, because it's never negative. So you have a plus c1, right? And we can rewrite this as, I'm going to put this e to the c1 first, right? Split that into here. Then you have a e to the natural log of x squared would be just x squared, right? Then you have exponential function and the log functions are inverses of each other. They cancel out. Then to remove the absolute value sign, we can just remove the absolute value sign. Then we have to consider positive or negative of e to the c1 times x squared. Right? But there's no reason to have a complicated constant. So I'm going to call this constant just c. Right? So therefore, we have a family of curves. It happens to be a family of parabolas. So these are the orthogonal trajectories. Right? So let's type it in. So I'm going to go here. All right, so we have y is equal to cx squared. All right, so let's see. So the original one's ellipses, so it's going to be the either bottom these two. All right, and we have a whole bunch of parabolas, so you can see that the last picture is the correct one because you have a bunch of red parabolas there. All right, so let's check the answer. Submit for testing. Alright, it came back. It looks like we got the equations correctly and the picture correctly. Alright, that's it. I hope that this was clear.